Hello, this is Mrs. Decker, and this is Objective 3C. I can explain the differences between a strong and weak acid or base. Now, strength of an acid or base is different than the concentration of an acid or base. So it's important to be able to distinguish between the two. So let's start by talking about what a strong acid is. A strong acid is an acid that will nearly completely dissociate in water, which means that all or almost all of the molecules of acid will break up to form the ions soluble in water. So our example here is HCl. So when you put HCl into water, it's going to almost completely break up into H plus ions and Cl minus ions. Strong acids are also strong electrolytes, which means that they will conduct electricity very well. Now, weak acids will only slightly dissociate when dissolved in water, which means that only a small percentage of the acid molecules are going to break up into the H plus ion and then their negative ion. Most of the weak acid molecules are going to remain whole. So a small portion, this example here we have is vinegar, a small portion of it will break up into H plus and CH3COO minus, but the majority of the vinegar molecules are going to stay combined in this form, which also means then that they are weak electrolytes, which means that they will conduct electricity, but not very well. Strong bases are similar to strong acids in that a base will completely dissociate into its ions. So our example is NaOH, so that is a strong base. When you dissolve that in water, it will almost completely break up into Na plus and OH minus ions. Strong bases, because of this, are also strong electrolytes, which means they will conduct electricity very well. Weak bases, much like weak acids, will only slightly dissociate in water. And it's important to note that most bases are weak. We have quite a few strong acids, but not that many strong bases. They are also weak electrolytes, which means that they will conduct electricity, but very weakly. So NH3 is ammonia, and that is our example of a weak base. It is also one of the reasons we have the second definition of acids and bases. So if you look at this, it is made up of one N and three H's. People would think, because of those H's, that when it is dissolved, it would give up one of those H's, but that is not the way it behaves. When it is dissolved in water, it steals an H from water and becomes NH4+, which is something that a base does. So even though ammonia does not have an hydroxide ion, the OH-, it's still considered a base because it will attract a hydrogen, which is something that a base does. All right, so now let's talk about the difference between concentrated and strength. Both this acid and this acid are very concentrated in the 12 to 15 molar range. This is HCl, and this would be vinegar. So it's concentrated because there is a lot of the acid molecules in the solution. Now, this would be HCl, that is dilute. It does not have a whole lot of acid molecules in the solution. This would be like a 1 to 2 molar solution. Same thing with this one down here. This is also vinegar, but it is a dilute version of vinegar, probably what you would get at the store, like a 1 or 2 molar. So if we look at the strength, looking at the HCl, most of it has broken up into H plus and A minuses. We have a couple that are still remaining HCl, but most of it has broken up into H plus and Cl minuses. That's what makes it strong. The same thing with the dilute version. Most of the acid has broken up into its ions. Now, if you look at the weak acid, a couple of ions have formed, broken up into the H plus and then the negative part. But the majority of the acid molecules have remained the same. That's what makes it weak. Now, you know that if you got 12 molar hydrochloric acid on your skin, it would cause severe damage. A 1 molar hydrochloric acid is not going to cause that much damage. It might irritate your skin a little bit, but beyond that, it's not really going to bother you. You should also know that vinegar, if you poured vinegar on your hand, it wouldn't hurt. So a very dilute weak acid is not going to hurt. However, this very, very concentrated vinegar, this 12 molar vinegar, would still be very painful, would cause a lot of damage if you got it on your skin. So the dangerousness of acids and bases comes from their concentration, not whether they are considered a strong or a weak acid or base. So it's important for you to understand that distinction. Let me know if you have any questions about any of this.